We're diving into the Sklearn's function, a tool from the Scikit-learn library used to estimate covariance matrices. It's a fancy way of figuring out how different variables in your data relate to each other. Think of it as a powerful statistical detective. This section poses a multiple-choice question testing your knowledge of the OAS estimator. Get ready to put your Scikit-learn skills to the test. I'm asking you to evaluate 4 statements about the OAS estimator and select all the true ones. This assesses your understanding of its key properties and functions. Statement A. The OAS method always gives us a positive semi-definite covariance matrix, a critical property of valid covariance matrices. I want you to think about the essential nature of a covariance matrix. Statement B. A key aspect of OAS is its automatic calculation of the shrinkage intensity. This happens without any direct control from you. The method determines the optimal shrinkage using an internal optimization process. Statement C. OAS is compared to a standard sample covariance calculation, particularly for large datasets. While generally more efficient for high-dimensional data, its computational cost still scales with dataset size, unlike the claim in the statement. Statement D. The OAS function doesn't directly have a "shrinkage" parameter for you to adjust. The shrinkage is determined internally by the algorithm itself. This quiz tests your knowledge of the Oracle Approximating Shrinkage (OAS) method in Scikit-learn, a popular Python library for machine learning. We'll explore several statements about OAS and determine if they're true or false. Get ready to put your Scikit-learn skills to the test. I find this statement true. A significant advantage of OAS is its automatic calculation of the shrinkage intensity. You don't need to manually set any parameters. The algorithm figures out the optimal amount of shrinkage for your specific data. This saves you time and effort. I consider this statement partially true. While OAS aims for efficiency, especially with high-dimensional data, its computational cost isn't always lower than a simple sample covariance calculation. It depends on the dataset's size and characteristics. It's more accurate to say OAS offers computational advantages in many cases, but not in all cases. I believe this statement is absolutely true. OAS is specifically designed to guarantee that the resulting covariance matrix is positive semi-definite. This is a crucial property for a valid covariance matrix, and OAS ensures it, regardless of the input data's quirks. That's a key benefit. I think this statement is false. OAS doesn't provide a direct parameter for controlling shrinkage. The algorithm determines the appropriate amount of shrinkage internally. There's no knob for you to manually adjust it. I found that statement A is true. The Oracle Approximating Shrinkage (OAS) method is specifically designed to ensure the covariance matrix is always positive semi-definite. This is a critical requirement for a valid covariance matrix. I discovered that statement B is also true. A really neat feature of OAS is that it automatically calculates the optimal shrinkage intensity. You don't need to manually set any parameters. The algorithm figures it out based on your data. I observed statement C is false. While OAS aims for efficiency, especially with large, high-dimensional datasets, it's not always computationally cheaper than a simple sample covariance. It's an approximation method, and the computational cost still depends on the dataset size. I noticed statement D is false. There isn't a direct parameter in OAS to control shrinkage. The method automatically determines the right amount of shrinkage. This question asks you to identify the true statements about the Oracle Approximating Shrinkage (OAS) method for covariance matrix estimation in the Scikit-learn library. Let's dive in and see what makes OAS tick. This statement is about a crucial property of covariance matrices: positive semi-definiteness. I'm telling you that OAS guarantees this property, ensuring a valid covariance matrix, no matter the input data. That's a key strength of this method. Here, we are focusing on how OAS handles shrinkage. Shrinkage is a technique used to improve the estimate of the covariance matrix. OAS cleverly determines the optimal level of shrinkage automatically based on the data. You don't need to set any parameter values for it. The algorithm figures it out itself. Pretty cool, huh? This statement is incorrect. I'll mention that OS doesn't provide a direct parameter to adjust shrinkage. The algorithm figures out the appropriate amount of shrinkage. This is about computational cost. While OS aims to be efficient, especially for large datasets, its computational cost isn't always less than a sample covariance. It depends on the data. It's a more nuanced point than the other statements. I'm talking about the OAS function, a part of the Sklearn library in Python. It's used to estimate covariance matrices, which describe how different variables in a dataset relate to each other. This is a multiple-choice quiz testing your understanding of how the OAS function works. This question asks you to identify the correct statements about OAS. You'll need to know what a covariance matrix is and understand the characteristics of the OAS method for estimating one. Statement A claims that OAS always creates a positive semi-definite covariance matrix. A positive semi-definite matrix is a type of matrix that has specific mathematical properties guaranteeing that the results are valid for covariance matrices. This is a key property to be always true for valid covariance matrices, and OAS is designed to ensure this. Statement B says that OAS figures out the shrinkage intensity itself based on your data. Shrinkage is a technique used to improve the accuracy of the covariance matrix estimation. OAS handles this automatically. You don't need to set any values yourself. Statement C claims OAS is faster than a simple sample covariance calculation, especially for large datasets. This isn't always true. While designed to be more efficient in certain situations, it can still be computationally expensive depending on the size of the data. Statement D suggests that you can directly control how much shrinkage OAS uses via a parameter. That's false. OAS calculates the shrinkage amount internally. We're exploring the OAS estimator from Sklearn's covariance module. It's a method to estimate covariance matrices, which are crucial for understanding relationships between variables in a dataset. I'm presenting a multiple-choice quiz to test your understanding of the OAS estimator's properties. Let's dive into the quiz questions. Each statement presents a claim about how the OAS estimator works. The first question asks, does OAS always produce a positive semi-definite covariance matrix? This is important because only positive semi-definite matrices can be valid covariance matrices. Next, I ask, does OAS automatically determine the shrinkage intensity, or does the user need to specify it? Shrinkage is a technique to improve the estimation of the covariance matrix. Here, I'm exploring the computational cost. Is OAS always faster than calculating a simple sample covariance? Computational efficiency matters when dealing with big datasets. Finally, I ask, can we directly control the amount of shrinkage in OAS using a specific parameter? Understanding parameter control is key to using any algorithm effectively. I'll reveal the correct answers to the quiz at the end. Let's see how well you understood the features of the OAS estimator. This section introduces the topic. We'll be exploring the properties of the Oracle Approximating Shrinkage (OS) estimator within the Sklearn library. I'll explain what OS does and clarify some of its key features. This section lets you know that you're about to answer a multiple-choice question testing your knowledge of the OS estimator. Get ready to put your knowledge to the test. Here's the multiple-choice question itself. I'll go through each statement and help you determine whether it's true or false based on how OS works. This question will focus on your understanding of OAS's behavior and capabilities. Statement A claims that OS always generates a positive semi-definite covariance matrix. A positive semi-definite matrix is a type of matrix that has only non-negative eigenvalues. This is a fundamental property of a valid covariance matrix. OS is designed to ensure that this property holds true no matter the input data. Statement B says that OS automatically calculates the shrinkage intensity without requiring any user input. OS determines the optimal level of shrinkage via an internal optimization process. This is a key feature that simplifies usage for users. Statement C states that OS is faster than calculating a simple sample covariance, especially for large datasets. While OS is designed for efficiency, it isn't always computationally cheaper than a basic sample covariance. The computational cost of OS depends on factors like dataset size and dimensionality. While OS is efficient for high-dimensional data, it might not be faster for all datasets. It's an approximation method, which means it sacrifices some accuracy for speed. Statement D suggests that OS has a parameter to directly control the amount of shrinkage. This is false. OS calculates the amount of shrinkage internally. There's no user-adjustable shrinkage parameter in OS. This section simply indicates the start of the answer options. It's a clear transition before the actual options are provided.